2025, a year of change and anticipation. Unexpected change rewards those who are quick to adjust, but all aspects of a system must be adjusted to keep growth going. 2025 has certainly been a year of unexpected changes. This had a significant impact on the semiconductor industry and everything that supports it. Not all the changes have been bad, but flexibility has been a requirement for a continued success or to make the most of opportunity provided. Some industries, such as aerospace and defense, are seeing a significant boost around the world. Data centers continue to grow, driven by almost insatiable demand for AI, and that's driving industry growth, despite the challenges in the supply chain. Several things have gone faster than I expected, including the announced investment in AI infrastructure, projected semiconductor and memory consumption, demand for power, and demand for advanced packaging, said Stephen Wu, fellow and distinguished inventor at Rambus. Some things are progressing slower than I hoped, including fundamental voltage scaling and advanced process node, the use of the high-NA EUV, and the standardized off-chiplet interfaces. Need for change was a common thread. I used to think the semiconductor world moved at a much slower pace, but the past 6 months have proven me wrong, said William Wang, CEO of ChipAgent. The onset of the AI-driven memory and storage super cycles, rapid shift in IDM strategies, and a surge in the demand for the agentic AI and EDA have accelerated innovation across the stack. AI is impacting the entire industry, either directly or indirectly. More engineers are being hired by the big boys. Everyone wants to make chips, said Shiv Shikant, Executive Vice President at ICManage. It had become all about the software, and everyone forgot about the hardware. Then you realize, hang on a second, software needs to run on something. And the chips are us. Again, we are gonna have more chips. And we are going to have better chips. Because AI tools have made us more productive. It's not just the chip. Pure play companies moved up and down the stack, creating new competitive pressures as well as new opportunities, said Uji Baruchi, Chief Strategy Officer for ProTintex. Chip companies began build full system and even data center scale solutions, while hyperscalers and device makers invested heavily in custom silicon. Entire ecosystem formed around these verticalized approaches, and with them came new business models. Companies increasingly found themselves involved not only at the silicon level, but also at the system level. And many entered the custom systems business to differentiate and capture more of the value chain. Supply chains. Supply chains around the world have been broken, and companies are racing there with the fallout. What really surprised us was how unstable our supply chains are, said Ed Hennig, department head of the efficiency electronics at Fraunhofer Tooth Engineering of Adaptive System Division. We have seen it is seen again in Europe with the Xperia problems. We expected that our supply chain would have become a little bit more stable after COVID, but they have become problematic again. We can no longer trust that we can get the devices from everywhere in the world. We need more local supply chain, maybe also more local solutions. The devices that are cost panics have caused problems, and it has destroyed the whole supply chain. The disappearance of the even of the simplest of the device can have a significant impact. OEMs are trying to set up supply chains that are less sustainable to disruption, including a company going bankrupt. So the Roland Jackie, head of the Department of Design Methodology at Fraunhofer IIS EAS. The problems in Xperia meant that Volkswagen could no longer produce cars. We no longer have the notion of the second source, while another company can quickly step in if the other company fails to deliver. Semiconductor manufacturing has started to become more distributed, changing the dynamic of the assembly and packaging. The name of advanced packaging is misleading, said Mark Sweeney, director of the product market analysis, a part of Synopsys. It jumped the gun. What is being done is assembly, which is something new. It has its own format, its own constraint. That also created some new opportunities. It is clear that classical packaging can't be done in Europe because it's impossible to do that with the European salaries, said Fraunhofer's Heinichi. But if we do advanced packaging chiplet, will you put more functionality into the packaging? Will the packages themselves are more complex? Then it makes sense to do this in Europe, because then you have added value, you build more trust in your supply chain. Storing chiplets. There is increasingly divided in the semiconductor industry between those who doing advanced chip assembly and packaging, and those continuing with the monolithic integration. 2.5D and 3D design methodologies have matured faster than expected, said Andy Nightingale, Vice President of Product of Management and in the Marketing at Arteris, CoWoS. For Velodirect and iCube 3, capacity expansion made multiple practical. ED flows finally caught up with the packaging physics, integrating thermal, stress and voltage aware closer. That shift also reached the interconnect layer, and also continue to evolve to manage latency balancing, bandwidth partitioning, and IP disaggregation across the multiple dies, effectively validating the connected design as a system level discipline. It's interesting how quickly chiplet verification has started to mirror traditional NOC integration methodology. That does not mean that it's easy. Chiplets are here to stay, but I don't think the yield challenges have been solved, said Nelson Carter, General Manager, Design and Verification Business Unit at Keysight Technology. Chiplet continue to be a very complex set of technologies, and the packaging of the multiple chips together continue to be expensive and difficult. It works, and had been showcased very well with the 13 3D memory stacking. But beyond that, there's still a lot of work that needs to be done in the space. Designing for the data center are adopting 2.5D integration because they have no choice. They have reached the electric limit and grow compute power that have to spread across the multiple dies. Most designs have not reached this stage, so the economics do not look at the attractive. I was never a huge fan of the chiplet because I believe in VLSI, said IS manager Second. Chiplets are diametric opposite of the integration. If it's not happening on the same die, that means you've got a wires between the chiplet, and it'll raise the wire that slow everything down, cause complexity, crosstalk, disturbance, and a side channel attacks. Integrated steel silicon conti- Integrated silicon continues to be the holy grail. But when the electrical limit has been reached, chiplets may be the easiest way forward. With traditional scaling words become undeniable, heterogeneous integration moves from an optional optimization to a essential strategy for meeting modern AI and HPC workloads, said Pritin Baruchi. What surprised many what surprised many was how quickly ecosystem alignment matured. Packaging technologies, EDA flows, and a test methodologies so advanced together, enabling architecture that only recently felt speculative. Yet as the integration density grew, so did the new system level variability and failure mechanisms that challenge the long held assumption about realities and coverage. It looks as if the trend will continue. Last year, we made a prediction that 50% of the HPC designs will be multi-die, said Shekhar Kapoor, executive director of the product management at Synopsys. 12 months later, industry reports and surveys confirmed that we anticipated. Multi-die design is reaching scale. Multi-die design have become a cornerstone of the advanced semiconductor design. This shift was driven by the two forces, the physics and economic limits of the monolithic scaling, and the explosive growth of AI and HPC workloads, demanding higher performance and efficiency. There are other reasons to be adopt chiplets beyond size. It's things like flexibility in your product lineup, such as Sweden. You can swap between the number of processes without having to redesign the whole thing. You just swap out for upgradability. If you have a new USB interface, for example, you don't have to redesign the entire chip. You just swap out the chiplet and you're good to go. There's advantages other than a simply performance and power. The industry is struggling to get there. At the chiplet summit, there was a frustration regarding chiplets, said Heinig. This is not the case for the data center side. For them, it was totally clear because they needed chiplets for performance. But for the rest of the industry, many companies have stopped all chiplet activities because there is no business model. Everything is more expensive if you go with the chiplets. But there are layers of light. In the last weeks, especially for defense and automotive, we have received requests to speed up which with the chiplets at Nihi. For certain companies, it's become clear that they have to spend a little bit more money, and chiplets can be a solution to secure their supply chain. They see advanced packaging and chiplets a way to do that. By using building blocks, you can then order processors from the new suppliers and gain flexibility. There are still many problems that have to be solved. What does a chiplet or 2.5D or 3D stacking look like when we are talking about chips that operate at tens or hundreds of gigahertz? That exercise calm down. What happens if there is communication chip and digital chip next to its aerospace application? The problem that are being solved there are much different, and because of higher frequency communication challenges, there's a tougher to solve, and we are seeing a lot of engagement in this space. And there has been some exciting research published. I just think it's gonna roll out a little bit slower. The industry may need to have patience. Chip Richard still aspiration more than the reality, says Swinen. It was overhyped, but eventually we'll get there. It's like the IPO revolution. People struggled. That took several years of standardization before it was ironed out. Chiplets are even more complicated than that because they're more involved, but eventually we will get there. Standard will be a cornerstone for more general adoption. Standards are progressing, and advanced packaging technologies are powering heterogeneous integration, such as Kapoor. This space development reflecting a fundamental industry pivot toward multiple design, and the U-shaped 3.0 specification was released in August, and the upgrade offered by high bandwidth interoperability and ecosystem upgrade that reduce risk and accelerate adoption, supporting multi-die design as a mainstream design strategy. To get a more option, open chiplet marketplace, some hundred technical hurdles need to be overcome. Thermal and mechanical stress analysis all are moving from niche into necessity, so the key side come down. If you look at the chiplet problems, it's not just can I package chips closer together? I have to look at what happened, chips closer together. I have to look at what happens to power and what happens to temperature and what happens if I stack too many chips on the top each other. If there is mechanical stress that'll change the aging of the chips. Exploring the things are not just from an electronics perspective, but from a multi-physics perspective. Is starting to be more of the necessity. AI adoption. The meteoric rise of the AI is impacting everyone. The explosive rise of Gen AI that reshaped to become semiconductor roadmap faster than even boldest forecasts suggested. Said a protein text, Baruchi. What began as a computer race quickly became a system-level transformation that exposed bottlenecks in the memory bandwidth, technology power integrity, reliability, and life cycle monitoring. The scale and pace of the AI development to push it to device complexity so unprecedented levels bring with a far deeper requirement for observability, predictability, and long-term resilience. Those barriers continue to address. Memory continues to be a key driver of the performance as expected. But the scale of the plant build out it will require tremendous investment in semiconductor manufacturing and advanced packaging to keep up. Says Rambus Wu. I expected the HBM would continue to in the spotlight, and there continues to be no end in their sight to be demand for current and future HBM DRAMs. The announcement of the Rubin CPX and the use of GDDR in the tandem with the Rubin and the HBM was a surprise, ensuring that the industry has confidence in the long-term viability and utility of the large language models LLMs and the need to be optimized hardware for different phases and use cases. But not everyone has been able to move at the same pace. What has been surprising for me is there's a big thirst for AI, but when it comes to EDA, the responses has been more nuanced, said calm down. what you see with foundationally matters, and what you see from OpenAI and Google and others, and how fast they release a new foundation model, and how fast it gets adopted. The EDA world definitely has a slight different perspective. There are several reasons for this. In 2025, we started seeding our efforts to step into AI. Because prior to that, it appears like AI had a lot of promise, but everything was changing so fast that marking sustainable engineering investment in it was in it was a little confusing, said the Pakashi Narain, CEO of Real Intent. The cleared out this year. The other aspect become clearer was the value of the AI from the point of view of training. Typically, any time of customers bring on new users of the tools, there is an element of training that is involved. The aspect is facilitated by AI, reducing the time to expertise of familiarity. Many aspects of the EDA flows are being improved. Significant progress was achieved in the development and deploy of the generative AI assistants or copilots. Sadananda Thiruvenganam, Director of the Product Management of 4AI at Synopsys. These copilots now provide expert guidance on tools and workflows, automated complex tasks such as RTL and forward test integration, and have greatly enhanced efficiency and productivity across design teams. AI agents are able to reason, plan, learn, and execute engineering tasks both individually and as a part of coordinated teams. By collaborating, the multi-agent systems can address complex and multi-step engineering challenges that are previously required extensive manual effort and expertise. There are also questions about models. What tasks are they really suited for? Agentic AI is a current flavor in vogue, but the LLMs are inherently flawed because they can't reason and they've been programmed in a way to please the user, says IC Manager Second. What is needed are word models. LLMs have been trained on wide guide datasets. Our genre, our news, our political polarization, and our societal problems are all first world problems, but where we the majority of the people on earth, they are not here. How are we helping those people? That's more important. What AI really needs to do is just help lift people out of poverty so that we can have a better world. Adoption of the AI has solidified views about good uses. We see a significant change that has happened in the many ways companies now demand that all AI should be delivered on-prem, said Commodore. It involves design and EDA and the IP, and most companies are not ready to let their IP go offsite into cloud. We found this out because we developed the application for the cloud and we had to pivot and modify them to be AI solutions that are on-prem. Data centers. Everyone is aware of the rate of the data center build-out, but exactly how big is it? The semiconductor industry is talking about become a $1 trillion industry by 2030. Just look at the growth rates, said Rich Goldman, Director, Electronics and Semiconductor Business Unit at ANSYS. That's a great mark for the semiconductor industry. But recently, Johnson said that NVIDIA, a single company, has the visibility into sale and black hole and looming through 2026, 5 quarters that will total $500 billion. That is triple the revenue from last year. That gives them half of the number that the semiconductor industry said they are going to achieve in 5 years. That not only surprised me, it shocked me. What growth is good? It requires the other parts of the infrastructure can keep up. I expected that planning for the AI infrastructure build out to keep sprinting forward. But what surprised me is the scale of the investment that is being discussed by companies, including Meta, Google, Oracle, and OpenAI said, ooh. The power required to support the proposed scale of the investment is mind-boggling. Power has become so important to implement that are being talked about in terms of gigawatts instead of tera operations per second TOPs or some traditional computer-related metrics. And that is sending a clear signal through the industry. If we are going to build the next generation of AI, we don't have enough power for uh, them said second. We have the yet solved the nuclear fusion. We are still reliant on the traditional energy sources. Today, the energy density required to be built these data centers isn't viable. We've said this before, but now we have a scale problem. There isn't enough juice. If you get how much juice is being generated, so just in terms of new power production, it all happening in China. There is a huge amount of power production, and they are able to scale. We are short on power. Silicon Valley needs to make things more efficient and drive efficiency. You don't necessarily need the numbers of transistors that we currently have in legacy architectures. Design houses need to top up. Power and performance and thermal limits have become a first-class design constraint, while the customization of architecture process and packaging is now happening in the near real time, integrating pre-silicon and post-silicon processes. Said Chip Agent 1. The industry responses to AI workloads has shown the hardware evolution can move just as fast as model innovation when the feedback loop between the compute demand and silicon capability tightens. There will create a divide between those that adapt and those cannot not make the change fast enough. Power and performance management have emerged as most significant limiter to future scaling, said Barucci. Solving is really the key enabler for the next line of growth, and will be the number of the strategic focus for everything connect a semiconductor conductor company. Verification. The James Wilson Research Group data showed another year of erosion of tons of first pass silicon success, with the majority of the spin caused by the shifting or incomplete specification. It helped to find birds faster. We didn't stop the spec drift, said artist Nightingale. Executable specifications are still more vision than reality. We are multi-flows are document driven, not data driven. The integration between the requirement and RTL and the test remained fragmented. Specification traceability remained the weakest link until specs become executable and continuously validated. The spin will continue. AI is driving the development of a new application. Verification AI is the obvious application, and we have seen the acceleration in this area, said David Kelf, CEO of Breaker Verification System. It is now is to predict the event of the executor specification, while the
manual specs are read by the machine that go on not create full test benches. However, my 2026 prediction will be a tailoring of this new technology with back to basics, a verification foundation that couples more traditional techniques with the AI front end, and thereby creating a critical, practical flow of the work on today's design across the verification process. There are also possibilities to tell verification strategies and tools to emergence design trend. There's a lot of replication and repetition in AI chips. At least at core AI chips that the real intent are in. Each of the replicated modules are somewhat simpler. The total size of the design is very large. There is opportunity to take advantage of this aspect, and what are the special attributes of AI designs that I can take advantage of? Can we create a new application or improve the existing application so they are more efficient for the scale of the design, which is happening for AI? Emerging technologies, some technologies appear to have been at the cusp of the cusp for several years. Quantum computing is talked about, and many say it is overhyped, said Sweden. And yet, if you look at the valuation of the quantum computing companies, they are continuing to rise. Companies like IBM and others are not stupid. They know what they are doing. They continue to invest in the quantum. It leads me to suspect they may more is going on than we know about. Why are these valuations so constantly growing up? And why do these companies keep investing? What is it that we don't know? Others share those views, but also see the potential and a possible disruption. There is a hype around quantum compute and what qubits can do, said Skander. It's exciting because things could change in such a dramatic way. For example, the quantum computer allegedly could transform Bitcoin computation. Even though there's not many coins left to be mined because of the finite limit, it could mine them in blink of the eye. It does bring technologies together. The convergence of the photonic and quantum is happening, said Kamdar. We can see quantum computing continue down this path. It's not mainstream by many means, but the research in quantum computing continues. Announcement of the 1000 qubit computers and more are happening. There is a lot of research happening within the Western world, but you are also seeing it happen in other parts of the world. Japan, in the other countries accounting, announcing major research initiatives around quantum computing. Photonics may be ready for the big move, too. Not totally unanticipated, but co-packaged optics is finally here, said Sweden. They've been around for years, but were always too expensive, too complicated. The technology wasn't quite there, so it had a limited application. Now there's a feeling that they have finally arrived. TSMC had thrown its weight behind the COUPE architecture by saying, "Here's the standard architecture that may have high enough bandwidth and reliable enough for a broad application." This is being pushed by the data center. The silicon photonic impact shorten whole communication from rack to rack and maybe even onboard on chip is definitely happening, said Kamdar. Within the AI industry and the $3 trillion that are being invested, money is longer than the only factor. There is enough investment and many money to made if we can show faster speed. if we can showcase faster speeds. Okay, I read this article 2025, a year of the challenging and unexpected. Thank you for your time. See you next time.